Hey everyone, welcome. You are in for a treat today. I'm Derek Weeks. I'm Vice President at Sonatype. I'm also co-founder of All Day DevOps. And today we're going to be talking about some research that we've been doing over the last 10 months and walking you through some tales and information about software development practices across open source projects as well as commercial software development teams. So this research that we're going to be talking about and these practices that we're talking about comes from the State of the Software Supply Chain report for 2019. It was released yesterday by IT Revolution, Galois, and Sonatype. My email address is up there because I'm imagining most of you haven't seen the report. If you want a copy of the report, my out-of-office message is on. You just email. You don't have to put a subject line or anything. You'll get a link back that goes to SlideShare. You can download a PDF. You don't have to register or anything for it. So if you do want a copy of the report, it's just weeks@sonatype.com. I'll put that up at the end as well. So everyone in this room that has a software development team has a software supply chain. And as part of this year's research, we looked at the different aspects of the supply chain, including 36,000 open source projects that we investigated. We also looked at 3.7 million open source components. We looked at behaviors across 12,000 different commercial software development teams and how they were consuming open source components as well as containers flowing through their supply chains and tens of thousands of applications. And we really tell the story of what's happening within your software supply chains to give you a better feel for that. So on the panel, I'm honored to have Jane Grohl, CEO of DevOps Institute, with us. Stephen Magill, who is principal scientist at Galois, also CEO at MuseDev. David Jones, our friend and director at Credit Suisse. Gene Kim, while he's in the program and spent 10 months with us doing the research and writing the report with us and spending countless hours on it, is running the conference. So can't be with us here today, but he's certainly here in spirit, and the research and data in the report that you'll see he played a very significant part in. To give you a feel of what's happening in software supply chains, just to get a sense, I told you all have one, but you might not realize how active they are. In Java development alone, there are 10 million Java developers around the world. Last year, those developers consumed 146 billion download requests of Java open source components. If you have JavaScript developers on staff, 6.5 million JavaScript developers download 11 billion JavaScript packages a week. It's about 50,000 JavaScript packages annually for those developers. And it also, in this environment, there are 20,000 new open source component releases every day across the open source ecosystem. Now, for your enterprises, what this means is the applications that you're building are about 85 to in some cases 95% composed of these open source components. So you're not writing all of these applications from scratch, but building with these parts. And the impact of that on your organization, if I can get the next slide to show up, it did. The impact is, if you just look at Java development alone, the average organization, when we looked across 12,000 organizations, was consuming 300,000 Java parts annually, or Java components. This comes from over 2,700 open source projects that you are relying on as external software suppliers. And not all of those parts are created equally. Some are old, some are outdated, some have security vulnerabilities. And in this case, 8.5% of them did on average. But as we think about these consumption patterns out there and the demand for open source components that are fueling the velocity that we want to maintain, if you want to do anything with managing this environment, you first need to get visibility to it. So I want to turn to David and ask him, as a large enterprise, you have 25,000 or so IT professionals in the organization. How do you gain visibility to what's happening with software supply chains that are feeding the bank? So if any people in the audience are working in large enterprises, how do you approach even getting visibility to this if you didn't know you had a software supply chain, before walking in here?
Yeah, sure. So it's very challenging scaling up something that works quite easily on a small team and then building it across an estate of users that's tens of thousands of users. And what I've found over working across several places, several enterprises, is that you have to do some quite fundamental things before you can even create that observability. So if you have many pathways of software into your organization, and you have many places where you can build and deploy from, it makes the challenge more complex in creating that observability. What you need to do is make sure that every path in to your supply chain and every path out of your supply chain has a way that you can manage that and a way you can create that transparency. And this takes time. You need to make sure that all your assets, all your binary assets are in a place logically that you can look at, that you can observe, and you can see what's in there. You need to see how things are built, how things are constructed. As best you can, because in larger estates it's harder to cover 100%, but as best you can, you want those builds to be consistent across your estate so you can observe things in a consistent way. And this gives you an idea of how you can start to make informed decisions. From there, you can look at how you could introduce controls or measures or whatever it may be. But first of all, it's being able to see what's going on within your environment.
So follow-on question. When you got to Credit Suisse, it probably wasn't the first question that you asked, but it's somewhere along the line you had to say, we have a software supply chain. How do I gain visibility to it? Was that a question that had already been asked before you arrived, or did you have to go and find ways to get to that observability?
Yeah, I think it's the same in most enterprises. You don't get asked to build observability. You get asked specific questions. So it could be you're asked a risk question. Do we have a lot of vulnerabilities in our software? It could be that you're asked architectural questions. Are we using many different types of the same solution? Do we have a lot of technical variance? And from there, that's when you need to create that observability. So you get asked point questions, and in the process of trying to work out how to answer them, you come to the conclusion that you need to build a view across your estate, across your pipeline, across all your software.
Yeah. So, and you also talked about like centralizing your build so that you can get visibility on this in terms of what you're actually consuming, what is composing your software.
Yeah, I would think it's the same in a lot of large enterprises where over the years, teams have grown up and built their own automation in their build process. So you get a lot of different approaches across the organization. Sometimes that coalesces and you get areas where people are doing similar things, but really what you want to try and do is provide solutions that anyone can use to get that consistent approach, and then try and build in benefits that encourage people to do that. As I said, again, when you're talking of user groups that are tens of thousands, it's very difficult to get that 100% coverage, but all the time what you're trying to do is just make that problem smaller and do this in an efficient way that reduces the friction for developers, and that's always the aim.
Yeah, it's always kind of the starting point of if you don't know what you have, trying to manage any part of it is useless because you don't know what's flowing where into your organization. So I'm going to get into this conversation. So you have all of these parts, hundreds of thousands or maybe millions of parts flowing through, whether they're containers or open source components, build artifacts, and other things, but not all of these are created equal. This is something that we studied within the research across the open source projects. Gene Kim and Stephen Magill did the brunt of this research for open source projects. And within the research, you'll see that they identified 5 behavioral clusters of exemplary practices, small and large development teams, as well as some that were laggards or focused on we're going to develop new features first over building in or remediating security vulnerabilities. And there were some top performers in the research that you did across these 36,000 open source projects. So some suppliers are good, some suppliers are not so good. So Stephen, you've done this research. How do you go and tell if you know which parts you're using? How do you begin to tell which things are good and which parts are bad?
Yeah, so we took as our primary quality metric a measure of how quickly components would update their dependencies. Because when you think about your software supply chain, it's not just about the direct open source projects that you're dependent on, but those projects have their own dependencies and so on, sort of transitively, in a pretty deep dependency tree. And so you end up inheriting any vulnerability anywhere in that tree gets inherited by your project. But you're generally only maintaining your direct dependency. So you're inheriting their approach to managing their own supply chain. And so that's the primary metric we looked at is how well do they manage their dependencies? How quickly do they update them when new versions come out? Initially with an eye towards security, right? Looking at security relevant updates. So when a vulnerability is reported in a dependency, how long does it take them to move on to a fixed version of that dependency? And we found a wide variance there, anywhere from the best projects taking a small number of days to update to the worst being 3 or more years to make that update. And then we actually found that update behavior in general was closely correlated with update behavior for security vulnerability. So actually, by and large, most projects stay secure by just staying up to date, right? They're applying these patches quickly, regardless of whether it's security relevant or not. And so, so in the report, we give a list of the top 20% by update hygiene, by how quickly they stay on top of things. So you can certainly go look at that. We also found that while the best projects from an update hygiene perspective were more popular, popularity by itself was not a good guide to performance according to those metrics. And so, when you're sourcing components, there's reasons to consider popularity. There's documentation, there's community support, and so forth. But you shouldn't make that the only metric that you consider when you're looking at these projects. You want to make sure they have good hygiene practices, good release frequency, and so forth, so that you're getting other benefits by importing them.
Yeah, so part of what we've been talking about in this research that came along, and I think a surprise for all of us, when we talk about, an application may have 100 open source components in it, or in JavaScript, 200 or 2,000 components in it, and each of these has dependencies on it. And it sounds like, boy, the more components you have, the more dependencies you have, the more complex it gets, the harder it is to maintain. So tell us about what you found on the impact of the number of dependencies on quality and other metrics, other attributes.
So initially, we went into this research with a number of hypotheses, things that we thought would be true, that we wanted to look to the data to see if they're supported or not. And one of those hypotheses was that it would be easier to stay up to date if you had a small number of dependencies, right? 3 or 4 dependencies, that's pretty easy to manage. And actually, we found the opposite was true. If you look across the population, those projects with more dependencies were actually updating their dependencies more quickly and staying up to date better. And so that was so surprising and unintuitive that we dug a little bit deeper and found that actually what happens is there's a correlation between the size of the development team and the number of dependencies. So the projects with more dependencies also tended to have larger development teams. And that's really where the release velocity, the staying on top of updates and so forth comes from. Because if you look at large teams broadly, they do a better job at staying up to date with those metrics.
Yeah, I think so. The interesting thing in this report as you go through it is we do state what the hypotheses were, and then we state whether those were actually validated or rejected through, and some things like you mentioned were obvious or not so obvious. Mm-hmm. And I think it's important. I want to go back to kind of the simple takeaways of this is we're talking about open source projects and dependencies and all of this and what's in your software, but you have to recognize that these open source software projects are really the suppliers to your organization. Your organization has chosen not to write this code from scratch, and you're working with 2,700 different suppliers out there, but quality actually has to come into play at some point. If you're not going to write the code yourself, how do you select these components? And is it on popularity or other metrics that come into play? So As we move in the report, part of the report, and a big part in Chapter 3 covers the open source projects, we also looked at commercial practices in terms of where were commercial development teams updating their dependencies? Did they have processes in place to update their dependencies? Were they applying automation or tools that help them manage the compliance of these components that were being used? And the interesting thing that was found in the report was that there were exemplar groups within this survey that we did at this point back in May of 650 developers, and it was saying that basically this exemplar behavior looked at, there were practices of, we have a process in place, we update dependencies regularly, we have a practice for removing troublesome dependencies. And the more frequently we were doing this, the easier it would get. So the exemplars would say, I'm considerably less likely to consider this behavior painful, right? I'm considerably less likely to consider updating vulnerable components as painful. But I want to get into a discussion with Jane of, as we think about, here are practices, you have visibility to components, you know that these things are good or bad, but how do we bring the right skills into the organization to manage our development practices in a way that you just can't say use good components and all of a sudden tomorrow everyone's organization is doing that? What do you have to think about from the skills perspective?
So if you think about supply chains and we talk about components, there's very much a human element. And sometimes I think we forget about the human element, particularly when we start to talk about some of the key aspects of DevOps. And so underpinning all of this are going to be people. And if people, you mentioned, Stephen, about the size of the development team. Well, those are human beings. And we use the word human, by the way, so that everybody knows, because regardless of anything else, we're human. And so when we look at kind of man versus machine or human versus machine, we need to make sure that we have to update our humans as much as we have to update the components. And there is a cycle to it. It doesn't happen organically. It doesn't happen via YouTube. Right? It doesn't happen necessarily off hour, because there is a sort of an assumption that the humans are going to be able to organically update themselves, so that there's auto updates that happen overnight, the same as they happen with technologies. So there has to be intention there. And I think when you look at the exemplars, particularly when we look at the higher level exemplars, even the smaller exemplars, I'm certain that when you peel away those layers, you're going to find intentional upskilling, right? Because again, the elements of the supply chain are only going to be as good as the individuals that create the recipes, right? That understand what needs to be achieved through the software supply chain, and also those that are helping to amplify the transformations, because they're the ones that know, what components, what needs to be updated. And a lot of it happens automatically. I understand that, right? That's part of our shift left, but there really does have to be an intentional effort to do that. And some of that's going to be mentoring, some of that's going to be through formal training, some of it's going to be through micro training. We're a really big proponent of micro education, where you learn one thing and then you take it forward and then you use building blocks and you learn the next thing. So I guess at the end of the day, the message is, don't forget there's a human element, right? Don't assume the human element is just going to upskill organically, because I don't think that's necessarily where we all want to be. And I also think when we start to look at these different categories, you're going to see somewhere in there, and maybe you can share a little bit more about what you found when you were exploring these hypotheses, in terms of what organizations did differently, perhaps, as far as their human element of the supply chain went.
Mm-hmm. Yeah, so we didn't, beyond size of development team, we don't have a lot of insight into how these teams work. I think in future years, it would be great to so that data we got from GitHub by looking at the GitHub projects and the statistics there. And there certainly is finer grained data about commit frequency of individual developers. I think we'd like to look at the code and see how complexity of code relates to some of these outcomes. And so, yeah, there's, I think in all of this, it's useful to say we got some really cool results this year, but I think we're just scratching the surface of what's there to be had from this data. But I think when you were speaking, another thing that came up is it's not just about sourcing the right components, but you need to be using them correctly as well, right? There's a sort of good and bad ways to use libraries and architect things and so forth, and that really does become about the development team and their skills and
sourcing the right humans.
Yeah.
Right. I mean, I think that that has to be a consideration there as well.
So, David, how does a big bank like yours think about bringing the right skills to the people to? Are you bringing them tools that are just easier to use, and because of that, does upskilling happen organically, or do you have to bring people through training exercises or retraining exercises within the organization? And are the newest developers that you're hiring easier to train than the people that have been at the bank for 20 years?
Wow.
Lots of questions there. So answer that in 30 seconds.
So I think across all large organizations, especially again talking about tens of thousands of users, you're not going to know very many of them. You're going to know just a small subset, and quite often the most vocal users as well. And these tend to be the people who are most interested in what's going on. I think when a lot of people will talk about a tools versus culture type thing, and this gets discussed quite a lot, I think quite often you need a minimum set of tooling. It's like a prerequisite. So there shouldn't be any debate. You need the right tooling to begin the discussion. Beyond that, it's people doing the right thing. So it's neither one or the other. You can definitely spend too much time on either and still reach failure, So you need a combination of both to be successful. I don't think there's any difference in people based on years of experience once they know what they're doing. I think individuals are just very different. So you get some people who care a lot about this type of topic and some people not so much. I don't write much code these days. When I was actively developing, I was incredibly lazy. So I probably resolved things just by doing something that made my job easier. And I suspect that paradigm is true with a lot of people. If you offer them something that's going to make their lives a little easier and it has the right result, that's probably a good thing to try.
Yeah, playing on that and kind of going back to that mountain image that was in the report, that when you make it, part of making things easier that we were seeing from some of the data is the more frequently that people were doing this kind of update behavior and knowing this is part of my daily work and we have processes around it, the easier it was becoming for them. And those people that were saying, we only update once or twice a year through these practices, we're finding it very difficult. So that kind of, if you climb the mountain every day, it's easier. If you climb the mountain once or twice a year, you're huffing and puffing by the time you get to the summit. And so I think that's just kind of part of the behavior that plays in. So another topic that I know we all kind of have different, certainly opinions and viewpoints on is the release speeds. So we're about DevOps. We're about velocity. We want to move faster than our competition, release new capabilities to market faster. But it also plays into, can we move faster and stay secure at the same time? And this is one of my favorite charts from the report. And just quickly, what it shows is those that are on the left side of the chart are releasing fastest. The further right you are on the chart, the slower your release cadence is. The further toward the top of the chart, the more popular you are. The exemplars that we found within these different clusters are the blue dots and the green dots. What we found is these that were updating fast, that had good release frequencies, good repair frequency, good use of various technologies and practices were the more popular components. But it didn't mean that the most popular components, as you mentioned before, were necessarily the best. So you couldn't choose just on popularity alone within this. So as we move fast, what choices do we make? Oh, pick the most popular thing out there. It doesn't always serve us well. But so this is a question that David asked before the panel as we prepped. As things go quickly, does it really matter if software contains security issues or issues at all?
Well, there is an argument. If you move quick enough, no one's ever going to find the problems in your software. Yeah. You just release ahead of people finding issues.
Yeah, we've got 200 deploys a year. Who knew it was in deploy 152?
Yeah, as with everything, it's a balance. You can definitely get things very secure and not move at all. But you also find that things like risk or architectural management, everything that goes into how you want your software to look, or how you want it to perform, or the quality, or whatever it may be, all these things take effort. And if you're able to assert those things quickly and through the entire development lifecycle and through the delivery pipeline, then you're able to do these things. You're able to become more secure, and you build better software, and you get the results you want. As I said before, quite often what we're looking to do, or what everyone should be looking to do, is to accommodate lazy people like me. So get the result that I'm looking for with all the other benefits as well, and look at reducing that risk or getting the best architectural result. Also, some of the things we're looking at in terms of security actually introduces best practice. We want to have more standardization of how our infrastructure looks. We want to make sure that things are built using code or configuration, and that's versioned and immutable, so we can see what's happened over time. And doing these things will naturally help you accelerate accelerate how you're deploying software, how you're delivering, and how you're building things. So you can very much build better software and build it more quickly. You always have to care about what that software looks like.
And by doing that, are you spending a lot more time on that if you built these things in the tools? I don't have time to spend on security because I need to really meet my release deadline, right? Am I spending more time on security?
I think as with any problem, you can solve it many ways. And you have to be very careful. If you solve a problem an incorrect way, you're going to slow everyone down and they will hate you. So I think you have to take these problems and figure out how you do them with the least amount of friction, or at the same time enabling people to do the right thing or get something they want back. I think you can move quickly and get a better result. I think it's very hard to go slowly and get better results.
So I'm going to shift over to Stephen. Mm-hmm. So Stephen, in the report, you and Gene are doing this research on these projects, and you find out that those projects that update their dependencies most frequently are also consequently updating vulnerable dependencies in that practice. So if I'm just updating quickly and updating my dependencies, I don't have to worry about security because I'm kind of covering it consequently.
So you do have to be careful there, right? So I think of it as updating quickly and releasing frequently and everything gives you this capacity for running experiments and improving various aspects of the software, right? But you have to be making good use of that, right? So if you're using those deployment opportunities to say, oh, can we push this dependency forward in terms of versioning, or can we fix this security vulnerability and still meet our requirements and everything works, then that's good. That's the sort of good practice, good use of that release capacity, right? But we did see in the data set, actually, there's this cluster that we identified as features first that is actually releasing very frequently and moving their software forward, but completely neglecting their dependencies and keeping them up to date. And thankfully, it's a small portion of the population, but it does exist. And you want to make sure you're not taking that approach, right? You're making optimal use of this capacity.
Yeah, the clusters are really interesting to observe. What are they doing and what are they not doing? So Jane, years ago when I read Continuous Delivery by Dave Farley and Jez Humble, part of what they talk about in chapter 1 is build quality in, right? How do we have to think about equipping the people in our organization with that mantra of not only go fast, but build quality in? The Phoenix Project talks about it as well. Don't pass known defects downstream as part of the first way of DevOps. But talk about that a little.
So, we're really moving towards the evolution of what we call the T-shaped professional. So if you're not familiar with the T-shaped professional, the stem of the T is your deep competency, right? And so we want you to keep elevating your deep competency, but we really want you to fill the top of your T with a broad base of other knowledge. So the more broad-based knowledge like security, right? So if you're a developer, you have to have some core security capabilities so that when you're writing code, it is a security-first approach, right? Security is everybody's responsibility. You have to have have some testing capabilities so that, again, you can become a test-driven developer, among many, many other types of. Now, you don't have to have, for the overachievers in the room, you don't have to be pie-shaped or broom-shaped or comb-shaped or whatever, because everyone's going to try to get deep competencies on everything, and that's almost unachievable because sooner or later you have to leave something behind. So I would encourage everybody, and I think the report really demonstrates that the concept of T-shaping really has validity in this context, because you could have those core security capabilities broad-based, right? So that you could start securing earlier on the whole mantra of shift left, right? Well, we can't shift left if people can't shift left, if skills don't shift left. And so that's part of your journey in upskilling, is being able to identify what do you need to put into the top of your T.
Yeah. No, it's a good point. And so we talk about, the report talks about the processes, the practices, the guidelines, the thought patterns, the automation, that plays into it. It's not just one-dimensional in that regard. So again, for those of you that came in late, if you want a copy of the report, you don't have to register. Just email weeks@sonotype.com. My out of office is on. There's a link in there that allows you to download the PDF. If anyone tried it and it didn't work, let me know, because there's like 80 people in here that are wondering how to get that. But yeah, you can have the report. It's really great. Gene, Stephen, myself, a bunch of others spent a lot of time on it. Once again, I appreciate the panel. David, Stephen, Jane, thank you very much for this quick exploration, and we're around for questions as well for any of you that have them. So thank you very much.
Thank you.
Thank you.